Math 63, Chapter 1, Section 1.2, and we are working the problems. We're looking at problem number 9. Copper pipe is manufactured in 3 types according to wall thickness. Use the outside and the inside diameter measurements from the chart to calculate the wall thickness as a decimal rounded to 3 places and as a fraction rounded to the nearest 32nd of an inch. All the measurements are in inches. So let's look this over. Here's the top of the pipe right there. And from the inside edge all the way through the center to that end, that one is called ID for inside diameter. And then for the outside diameter, it's from the outside edge here to the outside edge here. Now they tell you that the pipe is in three different types. These are the sizes, okay? And don't let that bother you. Sometimes the problems include numbers that you really don't need in order to answer the question. But these are the 3 types, and you'll note, and it represents inside diameter, and this one is 0.402 and 0.43 and 0.45. These are inside diameters. And here, the outside diameter for this size pipe, for that size pipe. So it's always, for this size pipe, it always has an outside diameter of this, but the inside diameter can vary depending upon the thickness that you want. So they want to know, again, figure out what the thickness is. And so we're only going to do part A. So we're looking at size 3/8, and I wrote that down over here. Let me scoot this up. I wrote 3/8, and they're interested in type M. So if I look at type M, the inside diameter is 0.450. So the size is 3/8, it's type M. The outside diameter is 1/2, and the inside diameter is this much. So I want to know what the wall thickness is if I know these two things. Well, the wall, I'll say WT for wall thickness, is just going to be the outside one, the larger one, minus the inside one. And I'm just going to wrap this in parentheses because there's a decimal in there. It makes it easier for me to read. But the thing that you have to be aware of, if you just subtract the two, you're going to get this part and that part. And we don't want that. We only want to know what the thickness is. The thickness over here is the same as the thickness over here. We're not interested in 2 thicknesses. We're interested in 1. So after I do this, I guess I should use a bracket here. After I do this, I'm going to go ahead and divide by 2. So let me go ahead and run this in my calculator. And it's, so I'm going to start with the parentheses, and I'll put in 0.5 just because I want to, minus that number, 0.450, and I didn't put the parentheses here or here, I don't really care, and then I'm going to divide by 2. Okay, so I end up with 0.025. Now the question asks me to tell the answer out rounded 3 places. Well, this is already going out 3 places, so I don't really have to do any rounding, and these units are all in inches. So that's my 3-place answer. Now, if I want to write this to the nearest 32nd of an inch, what am I going to have to do? I have to take this guy and multiply him by 32. And when I'm going to go in the sandbox for a second. So I took this guy and I multiplied him by 32. Let's scoot that over. And I end up with 0.8. And I have to take this now and round it to the nearest whole number, which is 1. And so this ends up being 1/32. So I'm going to come back over here, and this is rounded off, so I'm going to say it's 1/32 of an inch. There's my 3-place answer, and there is my answer to the nearest 32nd of an inch. And the process that you see here would be exactly the same for all 3 of these guys. The only difference might be this one we didn't have to round because it only went out 3 places, but maybe one of the other ones that you do, if it went out further, then you would have to round to 3 places. This is problem number 10, and then we'll stop this video. This is about pilot holes. If you don't know what a pilot hole is, if you've ever driven a nail into a piece of wood or maybe a screw into a piece of wood and it's split, That's because the wood is probably too dry and you're pushing the wood around too much and it can't take it. So it breaks. So one way to get around that is to first drill a hole in the piece of wood before you put in the nail or the screw. Now, the deal is well, how do you know how big of a bit to use in order to drill this hole? Okay, so if your nail is like that thick, you don't want to drill a hole that's that thick. That would be crazy. The nail is just going to float around in there. Okay, so if you want the nail to bite the wood as you drive it in, then you want the hole to be just a little bit smaller than the thickness of that nail. Well, I'm going to pretend that this is a nail. Okay. It could be a nail or it could be a screw. It doesn't really make any difference. But if you want it to grab the wood and be a little bit tighter, then the hole that you drill has to be a little bit smaller than this. If you want it to just slip right through, and we would want to do that maybe if you had a bolt that slips through, then you want the hole that you make to be a little bit larger than what the screw or the nail is. And so these holes that you're making are called pilot holes. All right, so here we have a screw size that we're going to be putting in something. And it's just a number that could have said pink, red, orange, and blue. And these are the diameters for these different sizes. Now, if I want to do a loose pilot hole, and I have to do this to the nearest 32nd of an inch, what I'm going to do to make it loose is to round up. And what I'm going to do to make it a tighter hole is I'm going to round down. Now, here's what that means. Here's the actual diameter of the nail or the screw of the screw. So I'm going to take, let me clear this. I'm going to take that 0.112 and I'm going to multiply it by 32. And I end up, so I'm going to multiply this by 32, and I end up with 3.584. Okay, 3.584. That represents 30 seconds. Okay, so and normally what we do is we round to the nearest whole number at this point. But if you want it loose, no matter what this is over here, you're going to round that up. And if you want it tight, then no matter what this is, you're going to round that down. So the loose pilot hole is just going to be 3, and you could and we're going to write it as 30 seconds, 3 30 seconds, and these are inches. Okay, 3 30 seconds, and the no, I said that wrong. The loose one is going to be 4 30 seconds, and the tight one is going to be 3 30 seconds. Tight, you round down. Loose, you round up. The only difference here is, and this is something that we agreed on a long time ago, is that anytime that you have a fraction that can be reduced, you would reduce this. So this guy would have to be simplified to 1/8 of an inch. So that's loose pilot holes and tight pilot holes. And you would do basically the same thing on each one of these. You take each one of these decimals, multiply it by 32 like we did over here, get that number. For loose, round that number up. For tight, just drop that off and you end up rounding down. Okay, that's it.